Hello everyone, today we're going to show you how to split the middle term. Factorizing trinomials or quadratics. So let's start. So we're going to have a whole bunch of exercises you can do. And by the end of this video, you should be able of doing factorizing all combinations of trinomials or quadratics. Anyway, so let's go assign each of these terms turn into like a little question. So this is A, this is the term A, like this is A, B, and C. I think we all know this, but you want to get into the juice right now, so let's get started. So essentially what you want to do is split the B term. So let's go split the B term. So a simple one would be like 3 and 13, that will equal to 16. To make it easier, let's just put the x so you can have an understanding what we're doing here. We could do another one like 4 and 14. 10 and, was it 10 and 16? 10 and 6. You can also do negatives. So, negative 2x and 20. That still works. But once you got a whole group of them, now you want to go pick a one that will multiply into the C term. So let's go find one. It's quite obvious, 10 times 6 is 60. So let's go rewrite the equation. So let's go rewrite it. So now I'm going to just put this here, because that's what it is. I'm going to rewrite to x squared plus by 10, x plus by 6x plus by 60. Then the next step is to, if I just copy this, shift, now copy, duplicate. No, I did it wrong. Control C, Control V, there we go. Deselect, Command T, move this, there we go. Oh man, the power of computer. And then what we've got to do is put these into brackets. And now you just simply just do h of highest common factor. So what's the highest common factor in this bracket? It's the x, because this being multiplied this x, and the 10 is being multiplied by x. So let's take out the x. Excellent. The next one is 6, because it's 6 times x and then 6 times 10. So let's take out the 6. Oopsie daisy, getting a little bit messy. As always, my math teacher saying we run out of space, and I seem to run out of space. So you don't mind, we're going to do it up here. So I'm going to draw some annotation. And then we're going to factorize again. What's the common stuff? What's the common factor? It's a bracket. It's the x plus 10. So let's take it out. And there we go, yippee-ki-yay, we have factorized x squared plus 16x plus 60 into this compact equation, I guess. And you can always test it out by expanding it. But let's go to the next one. So here's a quick exercise. I want you to quickly do this. Pause the video, or you can follow along. So I'm thinking of factor. Right. So I think you can probably do this in your head, but I can think of a factor. Is 8 and 3. That will multiply to 24 and will add up to 11. So I'm going to rewrite this: x plus by 8x plus by 3x plus by 24 brackets. This is how I normally use it on pen and paper. And I'll take out the highest common factors. Remember, there's actually a plus here too. And then now we just factorize it again. No, take out the highest common factor. Ooh, be generous. Superb. Now we can actually factorize ones with positive. And you're going to be like, how we do negatives? Alright, negatives is the same thing, same deal. So, what are some factors? Alright, I'm sorry, I should have gone. Alright, so this is a simple one. We're going to get into negative, just like a simple negative one, and then we're going to get to some more complex negative ones. So, what is the factors to 1 and 8? Or, yeah, I would recommend you to think of like factors of 1 and 8. So, I will just write them down here. So 1 times it by 8, 8 times 1, but it's negative, so we put minuses in one of these. And if we add them up, which one will equal to 7, which is this one. So let's go rewrite the equation. Square plus it by, negative 1, x, important, plus it by 8x, minus about 8 in overall. And then we just do the same thing, brackets. Alright, take out the highest common factor, x simple. I actually recommend you to keep the 1 in the front just to make it simpler. If you're not that confident like me. So I'm trying to make you less dumber. There we go. That's 1. Now let's do this one. So we're going to take out the 8. So we're going to take out, it's actually a positive 8 right now. Here's a positive 8. Because a negative, positive times a negative equals into a negative. And there we go, we have essentially done it. So now let's go take out the brackets from this, which is the x minus 1. And yippee-ki-yay, we have successfully factorized this equation into something quite simple, compact. Let's do another one. This one's not going to be that quite clear. Alright. What is this like? What are you going to do? Well, simple. Just do what I say. Figure out the multiples. Just write down all multiples from the negative. So I'm thinking of 2 times what's half? Oh dear, I'm not very strong. 1 times tables 14. 2 times 14. That works. 7 times 4. And we can just go on and on, but I know one of these is the answer. So let's go try 2 times 14. Does that equals? Oh wait, it's a negative. So what you got to do? So if it's both a negative. So if the c values are negative, obviously one of them have to be a positive or negative, or the one the other way around. And so far, I think you can obviously figure out it's probably the 7 times 4. But which one? Is it negative 7 or positive 7? Or, is it this way or is it this way? Quite simply to answer that, you just figure it out. So it's negative 7. Yeah, here it is. So negative 7 plus it by 4 will equals to negative 3. Excellent, shouldn't. So let's go rewrite the equation. Since we found a true condition. Sorry, my X just looked like an N. Alright, shun. Alright, now let's go put the brackets in. Okay, do I got more canvas space? Yeah, I do. Alright. And then let's just take out the highest common factors from both of these brackets. And this one, we've got to take out the 4. X minus it by, yeah, the 7 goes into there, of course it does. Look at positive 4 times it by negative 7 equals to negative 28. So that's a true factor, that's a true statement. So now we're going to factorize these again. Oops, not thinking straight. Too busy. I'm too busy thinking of my life problems right now. Alright, cool. Now we have factorized it. Alright, let's do the last one. I'm pretty sure you guys can figure out in your head already. But go ahead and pause the video. If you don't feel like it, you just want to hear my voice and see more examples, just go ahead and watch. So let's go do it right now. Let's do it right now. So what's the multiples of this? We got 2 and 6, 3 and 4, 12 and 1. Alright, cool. Alright, so it's a negative, so we need to go minus it, and this is negative. And then it's definitely going to be this one, because 3 minus 4 is 1, which way is a negative 1. I think it's a negative 4, yeah, it's negative 4. So x squared plus it by 3x minus it by 4x minus it by 12. Yep. And we're going to do this, put the brackets. Tell me if I'm doing something wrong in the comments. That'd be really nice if you guys do that. Just teaching myself doing math here. Let's take out the highest common factors. Alright, 4 goes, so it'll be negative 4 x plus by, yes, plus 3. And then we take it out again. Alright, cool. So now I'm pretty sure everyone knows this good way of checking. So let's go check our answers. So a good way to check your answer is to expand them out again. So I hope you guys understand what FOIL is, or crab clause. So we're going to multiply x by these, and we're going to multiply 4 by this. Alright. So let's go. So x times x is x squared. X times it by negative 4, so it's negative 4 for x. 3 times x is 3x, so that's a plus x. And then 3 times 4 is negative 12. And hey, we've got something similar to here. Let's go add these together. Now let's go group the like terms. So negative 4 plus 3 is negative 1x, and then x squared multiplied by x, so by 12. And hey, we got the exact, cool, now we got the exact same answer as up here. So we did it correctly. Congratulations, you have graduated from basic splitting term school. I hope you use your power well. You gotta use your power well. You can't do anything with this really. It's just only exists in math. Maybe you can use it in physics, but I hope this helped.